What if I told you there is a volcano on another planet? So large that standing at its base, you couldn't even see the summit. A mountain so enormous, it makes Mount Everest look like a foothill. It's real. It exists right now in our solar system. It's called Olympus Mons. And by the end of this video, the numbers will genuinely stop making sense. Olympus Mons is a shield volcano, the same broad, gently sloped type as the Hawaiian volcanoes here on Earth. But on a scale that has no comparison. It rises 21.9 kilometers above the Martian surface. That's nearly 2.5 times the height of Mount Everest above sea level. And it is so wide, 600 kilometers across, that it would cover the entire state of Arizona. And at its base, it is surrounded by a cliff, an escarpment up to 8 kilometers high. 8 kilometers, taller than any mountain on Earth, just sitting at the base of a much larger mountain. At the very top is a caldera, a collapsed volcanic summit depression. 80 kilometers wide, with internal cliff walls hundreds of meters high. This isn't just a mountain. It's a volcanic complex so large it has its own internal geology. Here is the number that genuinely breaks perspective. Olympus Mons is so wide, and its slope so gentle that if you were standing at its base, and you look toward the summit, it curves below the horizon of the planet before you can see the top. That's not a metaphor. The mountain is so large that the curvature of Mars itself hides the peak. The slope rises at less than 3 degrees. You would walk for hundreds of kilometers across the volcano's surface, and you would be standing on what appears to be a perfectly flat plain. From orbit, Olympus Mons is visible as a distinct feature on the face of Mars. Its caldera visible from space as clearly as the polar ice caps. This is not a geological formation. This is the largest single volcanic structure anywhere in the solar system. If you're enjoying this, consider subscribing. We explore questions like this on the channel. On Earth, our tectonic plates are in constant motion. When a hot spot in the mantle begins feeding a volcano, the plate moves over it. The volcano goes dormant as the crust moves away from the heat source. And the hot spot keeps building a new volcano on the new section of crust above it. Mars is different. Mars has no active tectonic plates. The crust is thick, cold, and essentially stationary. So when a hot spot in the Martian mantle began feeding a volcano, it kept feeding the same point on the surface for billions of years. The result is what you see here. Billions of years of eruption, layer upon layer of lava, accumulating over the same location. Building a monument to geological patience. Is Olympus Mons still active? The honest answer is, we don't know for certain. Mars has no seismic monitoring network capable of confirming current volcanic activity. But geological evidence suggests it is currently dormant, not extinct. The last eruptions may have occurred as recently as 25 million years ago, which in geological terms is the recent past. Today, Olympus Mons sits silent, a 3-billion-year-old monument to what happens when a planet builds a volcano without interruption. Its escarpment cliffs tower above Martian dust storms that rage at its feet. The volcano rises so high that it punches through the thin Martian atmosphere. At its summit, the atmospheric pressure is less than 1/10 of the already thin Martian surface pressure. Olympus Mons does not just rise above the plains of Mars. It stands above the weather of an entire planet. A shield volcano on a world with no moving plates. Built over billions of years, layer by layer, into something our planet simply cannot produce. Thank you so much for watching. If this gave you a new sense of what's out there in our own solar system, we hope to see you again. Until next time.